recorded. If that makes you uncomfortable, feel free to drop at this point. So not going to have too many updates today. I really want to make sure that we give plenty of time for Steve. I know it's a rather complex topic. Thank you all for joining. I know that it's going to definitely teach all of us a lot. So just a quick rundown. Dave isn't here today, but myself, Kendall Roden, a member of the Cloud Native Global Black Belt team at Microsoft. We run these calls. They happen every other week. And I think most of you have had the opportunity to join before, so we appreciate you being here today. Definitely recommend sharing your feedback with us, giving us any topic ideas you have. Want to make sure that this is as relevant as possible to everyone joining. So we initially created the office hours really just to provide an opportunity for us to connect directly with AKS users to talk about the most recent updates, changes to the product, get feedback on kind of what you're working on, and then cover other cloud native related updates. So for today, we're going to be talking about bringing your own private DNS zone for AKS private clusters. That's kind of what to expect. And then I really want to emphasize that I know I mentioned this before. And can everyone hear me? I'm hearing some feedback. I'm not sure if maybe someone's off mute. Perfect. Awesome. So we have officially gotten confirmation that the product group will be joining us every other month to do a AKS roadmap call. So that'll be happening very soon. We already have, I think, 2 or 3 sessions that are on the GitHub page coming up. So we'll make sure that we really amplify that session. I think it's going to be really, really useful and an opportunity for all of you to talk directly with the product group and get questions answered around AKS roadmap. If you have any thoughts or questions, please feel free to reach out, and keep in mind that all of the recordings and content will be posted to the GitHub page after the call. So wanted to go through a couple of quick AKS updates. Honestly, not too many this week. Went ahead and put a copy of the release notes, which are also linked to the GitHub page as well. Just a couple call outs here. There are some updates happening to Calico with breaking changes, but it's only really applicable to China Cloud and government cloud. So just keep in mind, if that does apply to you, that you take a look at Calico implementation and make sure that it's up to date. We already have talked about pod security policy being deprecated. That's happening this summer, so keep that in mind. There were several changes and bug fixes that were made, so just wanted to link those here in case you want to go check out those more in depth and see if any of those are applicable to you. And then one call out is that the AKS legacy Azure AD integration is actually going to be retired on February 29, 2024. So luckily that's 3 years from now, so not happening anytime soon. But I do think it's a good call out to just say, if you're not already using the AKS managed Azure Active Directory, you should probably consider doing that, right? That's something that I wouldn't wait 3 years to do. You don't have to worry about creating the client and server applications for Active Directory. You can have AKS manage that for you. So definitely going to be a much better experience. But just good to know that down the line, that is something to be cognizant of. A couple ecosystem updates. I did get feedback on the last call to go ahead and put these in link form so that you could access them directly. So I'm going to go ahead and drop them in the chat window. I'll also put them on the GitHub page, but I'll do a quick rundown. But I will drop those in the chat after I'm done presenting, just so that if you want to access them, you don't have to go through the whole PowerPoint process. So a couple of things to call out. Azure Red Hat OpenShift is now supporting OpenShift 4.6. So most of you I know are AKS users, but you may be running OpenShift clusters as well. So just keep that in mind. There were a couple of good blogs that came out on the Terraform site. One of them was just talking about mono repo versus multi-repo. I think that this is just, one of those religious debates that we have within the tech community. There's, a lot of opinions on both sides. This really does apply to any kind of infrastructure as code. It doesn't necessarily have to be Terraform, but definitely think that's worth checking out and just seeing, I guess, an opinionated perspective on that. And then another call out is just that the V2 version of the Kubernetes and Helm providers for Terraform are now available. So I think that this kind of includes some updates around the authentication flows, some resource behavior alignment, some upstream API work that was done, and some weight conditions. And then also Helm V2 is no longer supported. So just keep that in mind. That's a pretty big update that happened at the beginning of February. And then Cube Weekly is a really great resource for anybody that's interested in just kind of understanding some of the updates weekly that are happening within the Kubernetes ecosystem. So I went through and just kind of called out a few of the main highlights. So there's a new site that was created that's basically kind of an amalgamation of recommendations around Kubernetes books for upskilling and just learning best practices. So I have a link to that. Also, a couple interesting articles, one around deployment anti-patterns that goes through a series of things to consider. It kind of talks through mixing infrastructure as code and application deployment, using things like Helm with Terraform, like some of the nuance there talks about, some of the things for your pod deployment. So definitely recommend checking that out. And then also one about how you can really leverage namespaces in order to do multi-tenancy. I know that this is a question and a topic of conversation our team definitely feels a good fit, so thought that would be useful. And then just a couple of event call outs. So KubeCon, Cloud Native Con, Europe virtual is happening May 4th to 7th. So definitely go check that out. I believe within the past week, they've done a closed, they're no longer taking call for content. So, go ahead and register, get that on your calendar. There's also an Edge Computing World Conference. It's a couple days conference that's basically all about, edge compute, running in a, hybrid type scenario, IoT, disconnected. So definitely recommend, taking a look at that. There is a code that I put here for 20% off the registration if you are interested in attending. And then last but not least, I also put a link here for some CNCF online programs. So they're doing a lot of really good online engaging content series. And there actually is one kicking off today with Liz Rice on container security. And if you haven't had the pleasure of hearing her speak before or reading some of her books, she's from Aqua Security, one of the major security container providers. And so, even if you're interested in joining that today, it's not too late. So through that link, you can sign up. And once again, I'll go ahead and drop all of this in the chat so that you can directly access these links. So without further ado, I'm going to pass it over to Steve to really get into the crux of today's topic, and then hopefully we'll have some time for you to ask him questions when he's done. Thanks, Steve.
Thanks, Kendall. Yeah, no problem. Can you hear me okay?
Yep, audio is good.
Cool. All right, let me go ahead and share my screen. All right, so the focus of today's discussion, we're going to talk about the new Bring Your Own Private Zone feature for AKS. Before we get into that, though, I do want to run through a bit of a level set on DNS in general in Kubernetes. There's a lot going on there. There's a lot of different components that come into play. And when I meet with customers and talk to people about it, there inevitably is a lot of confusion that pops up as far as, where resolution's happening, what resolves what. So I wanted to dig through a little bit of that first before we get into the Bring Your Own DNS topic. So, first of all, as far as resolving all the things, just to be aware, when we're talking about things like cluster resources, or things running within the cluster itself, running within pods, trying to resolve services, and many of you probably already know this, but I do want to run through it just to level set for those who aren't familiar. We're talking about CoreDNS, right? So CoreDNS replaced a prior capability called kubeDNS. It's an open source project. You can go take a look at it. It provides a ton of features. Effectively, it's a Go-based lightweight DNS server that runs within your cluster. So you'll see these CoreDNS pods. If you deploy an AKS cluster and look at the kube system namespace, you're going to see these CoreDNS pods running within the cluster. You're also going to see a service that will end up getting created for CoreDNS as well. Actually, we might not see it as a service, but there is a service IP effectively that you have to provide. When you create the cluster, you may have noticed if you've ever done advanced networking settings, you're going to say, here's my service CIDR, here's my pod CIDR, and what's my DNS IP address, right? So that DNS IP just has to be something within the service CIDR. So that's all feeding CoreDNS. And we're going to dig a little bit more into that and how it works in a second. The second layer is, okay, we're outside the pod now, we're on the node, and the node has to do resolution, or maybe you actually want to resolve the node name itself. Where is that resolution coming from? That comes from the Azure VNet itself. And if you go and look at your Azure VNet, you can go and you can choose to use the Azure provided DNS, or you can bring your own custom DNS. And again, we'll talk about that a little bit more. So with your own custom DNS, maybe you're running a bind server, maybe you're running info blocks, whatever it may be. And then the last component of the DNS story within Kubernetes is what we're really going to focus on for today's topic, which is the Kubernetes API server. Okay, and what we're going to cover kind of towards the end of the topic here is the the main ways that you can basically enable that API server if you're doing a private cluster, right? So I create a private cluster. It's going to get a private IP address for me, but I need to be able to resolve that private IP address to some host name. What are my options for doing that, right? So if you don't do private cluster, you're going to get the Azure public DNS. If you are doing a private cluster, you have the option to let Azure create and manage a private zone for you, bring your own private zone, or bring your own DNS entirely. So just a quick overview of what we're going to be covering in the topic today. So with that, let's jump into briefly the CoreDNS topic again. I'm not going to spend a ton of time here because this wasn't really the main focus of things, but just so you understand kind of what we're talking about when we're dealing with CoreDNS. Okay, so if you look on the left-hand side here, this is a Kubernetes cluster that's running within a VNet and a subnet. It's like a 2-node cluster that I have going here. I'm running my app, cool app, in its own namespace, so it has its own service, has a bunch of pods. For the sake of demo and analysis, I'm using DNS utils. So it's a pod that you can go deploy yourself. It's just a container image that's preloaded with tools like dig, NSLookup, and so forth. And then you have the kube system namespace. And this is what I just described, right? That within kube system, you're going to have some CoreDNS service that's taking these requests in and sending them to backend pods where the CoreDNS, actual DNS server resides. Okay. So from that end, if we're running within a pod, so say I'm remoted into this, I'm connected exec into this DNS utils pod, and I do an NSLookup for my cool app service, right? I want to get to this cool app service from my DNS utils. What's going to happen is DNS utils is going to go out, my NSLookup is going to go out. It's going to hit CoreDNS. So that's this line right here. CoreDNS is going to say, oh, cool, that's a service. I know the IP address for that, and it's going to return that back. And that's using standard DNS protocol. It's UDP, port 53, all that good stuff, right? So it's just getting the name back. You can even do reverse lookup. So if you have an IP address and you want to get the name of the service, for example, there's a way that you can do that as well, okay? The second one, for if we're doing a node lookup, so let's follow that path. So again, I'm in my DNS utils pod, and I go to do a node lookup. What's going to happen is this NSLookup is going to go, it's going to hit CoreDNS, because all DNS requests within your cluster always get routed through CoreDNS, right? That's the way Kubernetes is configured. It's going to send all that traffic to CoreDNS. CoreDNS is going to say, I know nothing of hosts. I don't know the VMs that are running here. That's not my responsibility. Let me forward that request off somewhere else. Okay, so CoreDNS at that point for the hostname lookup is going to go and pass that out to the VNet DNS, right? Let's assume for the purposes of this that VNet DNS is just the out-of-the-box Azure, I didn't touch anything, standard DNS, okay? That VNet DNS uses something called the Azure Recursive Resolver, okay? So there's this IP address that you'll see, I don't have it offhand, it's like 168.16. something. That's the recursive resolver for Azure. It's going to forward that request out there and get back the host name, okay? In particular, if this host name was created with your standard DNS, it's going to be like an internal.cloudapp.net zone that's resolving. It gets that IP address back and says, hey, DNS utils, here's the IP that you looked for, okay? The final one here, the final lookup scenario that we're going to talk through is if you're doing a public lookup, right? So NSLookup from here out to get Microsoft.com. Okay, so that's going to come out this way. It's going to hit, again, always through CoreDNS. It's going to then forward that out to the Azure DNS on the VNet, because CoreDNS doesn't know where Microsoft.com is. Sends it out to the VNet DNS. It's going to then pass that out to whatever your public DNS may be. These lines may be wrong. They may actually go through the recursive resolver. I have to trace that. But ultimately, it's going to go to 8.8.8 or 1.1.1.1, whatever your DNS of choice is for that. It's going to resolve that DNS name, get it back, and return it to you. So I think the key point to highlight with this, as far as CoreDNS is concerned, is that because it's the focal point of all these requests, you have the option to really mess around with things in good and bad ways, right? That you have the ability to intercept requests and do what you will with them in this scenario. So let's take a quick look at what that looks like. So I did upload this. This is just a quick CoreDNS example. And again, I'm not going to spend a ton of time on this, but this is out on the GitHub repo. We'll share the link with this. This just runs through some basic configuration demonstrations for CoreDNS. So in this case, I created just a simple basic cluster. You can see there's no special flags on there. This is just a raw AKS cluster. Got the credentials for it. And then I deployed my DNS utils pod. And this is actually copy paste right off of the Kubernetes.io documentation. Again, this is nothing special that I did. This is just a straight DNS utils, okay? Now from that point, I can start running execs into this. So let's go in here and let's Just so you're aware, in this bottom window, I'm actually doing a follow of the logs. So if I cancel this, let's cancel this, clear it, and let's run it again. You can see I'm just doing kubectl logs for CoreDNS, and you're gonna see those start to stream through. Okay. Now up in the top here, I can do, I have aliased k to kubectl, as most of you probably have. I'm gonna do k exec -it DNS utils -- ns lookup, and actually let's just bash into it. Might be sh because I'm gonna run a bunch of commands here. All right, let's clear this. Let's do ns lookup of Kubernetes, right? Because there's a Kubernetes service within our cluster, and sure enough, you can see it goes and finds kubernetes.default.local. If you look down in the bottom here, you can see where it's actually doing that resolution. Right, so it went out and got that service local IP address. Okay. From here, I could go out and let's do the same thing for, let's do Microsoft.com. Okay. Now, one thing that's worth noting, just so you're aware, because you might not be aware from the DNS perspective, you see this fun stuff happening, right? Where it's taking Microsoft.com and trying to append .default.service. It's basically saying, hey, what is the fully qualified domain that I'm looking at? The reason that it did that is because officially a fully qualified domain actually ends in a dot, if you weren't already aware, right? So it's going to go through and try to find that FQDN, and eventually it's going to say, oh wait, I'm just going to try Microsoft.com dot, and boom, it finds it down here and gets the response back. Okay, so I can run that, and sure enough, with the dot on the end, you can see it was actually much faster. It didn't do all of that extra cruft that's in there. Okay, so let's do something a little more interesting. Let's actually break this a little bit. And this is the last thing I'll show, and then we'll move on because I know we want to focus on the other area. So if you go out and look at the Azure docs, and I shared the link to it here, we do have the ability to customize CoreDNS to a point. Okay, so this is a very simple configuration. Actually, I already applied this one, so we'll skip it. But this is basically enabling more verbose logging, right? So if you're running CoreDNS by default in AKS, you're not going to see all of these lookups. But if you're trying to debug some issue, if you apply this, and again, this is straight copy and paste from our docs, it's going to do log override and increase the log level, and you can add some additional configuration options within there as well. Okay. And then, of course, if you make a change, you can either wait for it to propagate or you can just force delete the pods. So that's all that this is doing right here. All right. But let's jump a little bit forward and let's do something a little bit more sinister. Okay. Or it could be useful. In my case, I'm doing something sinister. Okay. So in this case, I'm going to break the internet. Right. So I'm actually going to modify that lookup so that any requests for AOL.com get forwarded to my own, which doesn't exist, DNS server. Right, so think of the implications of what you could do here. If you have, internal IP addresses or internal routes that you need to look up, you can actually inject those directly in here and forward those specific requests directly from CoreDNS. So let's grab this value, and again, this is pretty much a copy paste directly from our Azure docs. Let me go. Let's exit out of this pod. Clear this. Apply that. Okay, so that configured. Let's do delete. I'm going to delete those kubedns pods to force them to reboot. Of course, my logging died, so let's fire that back up here. Okay. And once that's done, oops, I didn't wait long enough. There we go. Okay, let's try that again. Now my logs are running. Cool. Okay, so now I should be able to go back and let's exec back into there. And in this case, it should, AOL.com should have resolved, but now if I do an NS lookup on AOL, and you'll see that eventually it's just going to time out, right? There's a timeout in there because effectively I just forward that traffic. It's going to be a server fail. I forwarded that traffic to a non-existent DNS server, and you can receive those requests coming in down here. Okay. Cool. So that's fundamentally CoreDNS and what it's doing. There's a lot more you could do. There's a lot of plugins. There's tons of kubecon sessions. But I want to make sure that we level set, first of all, on the fact that CoreDNS is there in your cluster. It is routing requests from inside the cluster, and it's its own thing, right? So you don't want to get that mixed up with the API server and what we're going to be talking about the API server. That's going to be a completely separate DNS capability. So let's kill this and jump back over to here, and let's move on to the hostname resolution really quick. First, let me actually do this just to make this a little bit easier to absorb. Hostname resolution, and this is an issue that comes up pretty often, in particular when you start messing around with your own cluster DNS. You bring your own DNS. So how does hostname resolution work within Azure? And this is completely separate from AKS, but it does impact AKS, right? So if I'm in a virtual network and I have node 1 and node 2, I'm using my Azure provided DNS. So in the VNet, if I go and take a look, I'll show you even where this setting is. If I go and look at, say, this sample, oops, that's a bad example. Let me go back to, this is a good one. And look at my DNS servers for the VNet, you can see I'm just using default Azure provided in this case, okay? So if I'm using that default Azure provided DNS, it's going to use that recursive resolver right over here. As nodes are coming online, those nodes get registered with the recursive resolver, right? So it's going to be like node1.internal.cloudapp.net. I didn't write that out because I didn't have room here. Give the IP address and you're good to go. So if node 1 says, hey, where's node 2? It's going to go out, call there, get the recursive resolver, get the A record, come back, and everyone's happy, okay? Now what happens if you bring your own DNS is a little bit more confusing, right? So node 1 goes out to a customer, your own provided DNS server. It says, I don't know node 2. No one has told me who node 2 is. You know, unless you've gone in and configured something to register those machines automatically, which there are options for that, right? Register those machines automatically, by default, it's not going to know. So you have to have some admin or, you know, again, an automation job or something like that with their seemingly massive machine over here, add those A records for you. So in this case, someone has gone in, or maybe an automation job has gone in, or some other, you know, registration tool has come in and said, hey, node 2 just came online, and its IP address is 10.0.0.5. Okay, so it's going to register that record for us, and now from that point forward, we should be able to resolve that. So how does this impact Kubernetes? Is that if you have an AKS cluster, and this comes up very rarely. I think I've like 1 in like 50 customers that I talk to have come across this. You've brought your own DNS server, and you're not doing a recursive resolver. You know, you start running all kinds of funky issues. If you're trying to do hostname resolution, I've seen customers who are trying to deploy specific Helm charts, and for some reason that Helm chart is actually looking up the hostname. You're going to run into issues unless someone has gone and created those records for you. Okay, and again, there's automation processes. There's all kinds of ways you can do this. But if you run into a case where you're running your own custom DNS and for some reason you're not getting your hostname resolution, this is most likely the issue, because without the Azure provided DNS and the recursive resolver, something has to go and create those records for you. So that's something you'll have to consider, even for your AKS clusters. All right, cool. So now let's get into the real topic that we had today, which is Azure. Let me pull these pages out here because I'm going to need these in a second. Okay, so is the AKS API server, all right? So if you go and create any normal cluster, you just go and like I ran that command before, and I can go and show you that, right? I said that I just created a standard AKS cluster. If I go look at my resource groups and look at, I think I have a CoreDNS. Yep, there it is. Here's just a normal cluster. I can go take a look at the resource group for that. Okay, if I take a look at this resource group, this is just a normal run-of-the-mill out-of-the-box cluster. I'm not using private link. I'm not using anything, right? What I'll see is basically you're going to get a couple components here. You have your VM scale sets for your node pools. So you have multiple node pools. These are in your subscription. They're your compute. They're your VNet. But then you're going to have this hosted control plane. So you'll see reference to a DNS name of HCP. HCP stands for hosted control plane. And it's where your hosted managed components of your Kubernetes cluster, right? The master node components that aren't running in your cluster, that are Microsoft's responsibility, they're all running in this hosted control plane, including the Kubernetes API server. And they're connected from your VNet via an SSL, an SSH connection, using connectivity. Used to be tunnel front. You'll see that transition starting to happen right now. So there's direct connectivity from these to that API server. But that API server itself is actually a public endpoint. So it's going to be like mycluster.hcp. Whatever the region, East US, .aznkh.io, right? Fully managed, public IP, publicly accessible. It can be secured with Azure Active Directory auth. You can do IP restrictions on there, right? And that's this kind of standard deployment, okay? If you don't want that public IP address, that's where you get into the bulk of what we're talking about today, right? Which is private zone, having private API endpoint. You don't want a public IP address on here anymore. Now, I like to push the debate there a little bit. You know, when a customer says, hey, we have to use private clusters, I like to push back a little bit and say, okay, but Why? Is this just a checkbox exercise, or do you really have specific requirements that drive that, or are you just doing it because it seems like the right thing to do? Because the reality is, a public API server, you can secure very well. You can do AAD auth, you can do multi-factor authentication, conditional access, all those things. You can do IP restrictions, so you can really lock down this API server very well. But if for some reason you cannot move past that, you absolutely have to have a private IP address. That's where the private API server comes into play. And there's 3 different ways that comes online, okay? 2, 3. So the first, option 1, when you're doing that setup, and this is the original option, this is the way that we've always had it. As soon as the API server wasn't able to be private, this is the approach that was taken. That basically, you still have your cluster subnet, your node pools that are in there. You still have an API server out there that's in the hosted control plane. That's all the same. But what happens is that public IP address for the API server gets walled off. And if you saw the session that Ray did, I think one of the first sessions for open office hours, he talks about how this architecture works. But effectively, what you end up with, that public IP address gets walled off, and you get a private link. So a private link is basically injects what would be a public service into a VNet. So it walls off, kind of firewalls off the public endpoint, and then creates a connection into that subnet. That private link is created and managed by Azure. But in addition to that, you also get a private zone. So if you're not familiar, Azure private zones are our private DNS, right? So we have Azure public DNS where you can go and create your public, A records, C name records, all that stuff. Private zones allow you to create those for your own private DNS. So we go and create a private zone for you. That private zone exists within the MC_resource group. It's a 1-to-1, right? So there's one zone created for each cluster, right? This gets dropped into the MC_. It's automatically linked to your subnet. Now, the interesting thing about that is, in order to automatically link anything to a subnet, you have to have appropriate rights. So this is an area where you can run into errors. If you go and deploy a cluster and your VNet has been locked down to the point that nothing can join it, well, you need to make sure that you've addressed that from an RBAC perspective. You can then additionally link this zone to other VNets. That's a user managed task though. So you would go in, if you have 5 subnets, five VNets, sorry, you would have to go to each of those that weren't the one that the cluster exists in and link that for it. Azure's managing those A records for you as well. This is a nice option. It works fine. The challenge is you get a proliferation of these private zones, right? You don't have a lot of control. So we really needed a better option that gives customers more control over these zone creations and how you actually manage those. So that's where the preview that just dropped in December comes into play, which is bring your own private zone. Okay, so how does bring your own private zone work? This didn't change. This is all the same. You still have a private link. Nothing changed on this side of the diagram. But on the right-hand side, we've made a bit of a transition. First of all, the resource group and the zone itself are completely owned and created and managed by the customer, whoever's creating this thing. It can be reused. You can have one private zone that has multiple clusters attached to it. You just have to create a private zone for like star.privatelink.whatever region.azmk8.io. And then because of that, we'll be able to manage the records in there. You are responsible, the customer, whoever's creating cluster is responsible for linking this zone to whatever VNets, right? So you've moved away from where Azure would automatically link it to you, and now you're responsible for all that. But you have one zone now, and you can manage all those records within there very easily, okay? So this is a really nice option that's now been exposed, and we'll show a little bit more about how this works in a second. A couple things to consider with this, similar to the last one, if you need to connect this zone to a subnet, well, you need to have rights to do that. First of all, the cluster needs rights because the cluster is going to be creating records. As you're creating new clusters, it's going to be adding records in here. So the cluster has to have appropriate rights. So you have to use managed identity. You have to authorize that identity. I think the minimum role is private zone contributor. It's in the documentation what that needs to be, but you have to have those rights. And then also whoever, as I mentioned, whoever's creating this and managing it does need to manage those links as well. Okay. But one thing to expand on this a little bit, I'm going to bring in another fly in here. All right, hopefully I'm trying to do this piece by piece so it doesn't get too confusing, right? Kind of to fly in here a little bit, we have this scenario, and this is the same with option 1 and option 2, right? So if you're using Azure provided and generated private zones, or you bring your own private zone, you still have this challenge where you have resources on-prem that are trying to connect in. And those resources could be in a CorpNet or some other network. So you still need some way to get that connectivity. In this example, I'm using ExpressRoute to connect in, okay? You need your on-prem DNS. There's no way to push the DNS from a private zone into Azure. What you actually need to do is have a forwarder. So if you look at the AKS or the Azure DNS docs, it'll explain to you that you can create a conditional forwarder for your on-prem network that will send requests into that Azure DNS and ultimately to that private zone. So that's something you have to consider. An alternative to that, if your on-prem DNS admin isn't interested in doing something like that, the fallback is always to edit your host file, whether that be Etsy hosts or whatever it may be. You can always edit your host file, create that record that says, hey, this Kubernetes API DNS name is equal to this private IP address. And as long as you have that private connectivity, you should be good to go. All right. So the final option in the setup, and I'm going to get in and show a little bit of how this actually, make sure I'm still on time, doing good, how this actually runs. Let's look at the final option. And this one it's a necessary evil. It's maybe a little bit more work on your side, but it'll give you full control, right? So this is a fully customer managed private connection, right? Private DNS, right? So forget about private zones. They're not anywhere in the picture here. You still have your private link, right? So your API server is still going to get a private IP address, but the DNS itself is going to be completely separate, right? So the DNS will be your own bind server, your own info block server, on-prem, in Azure, wherever it may be. That's your responsibility. You're creating the A records within there. Most likely, you'll start off doing that manually, but at some point you'll probably create some automation that does that. So as new clusters are coming online, you can automate the creation of those records, okay? You're responsible for making sure that whatever VNets are consuming this have that DNS entry in the VNet configuration. Along the lines of this, you'll also need to be aware of that recursive resolver, right? So if you're trying to resolve any Azure resources like SQL DB or anything like that, your DNS server needs to be aware of that. And that's all documented pretty well in our Azure DNS docs there, like what those flows look like and how they all work. In fact, I think I have a link that I'll share at the end here. We jump over to links. We have this doc that runs through all, I'm not going to run through all these, but it runs through all of the different scenarios, right? So all the different flows that can happen, right? So this is, a single VNet with a Azure provided DNS, and then this is multiple VNets with Azure private DNS, right? Runs through all these scenarios, and I shared this link, and you'll be able to take a look at that, and this should hopefully help you understand what's happening there, okay? So with that, and I know we want to get to questions too, I want to run through and actually show this running in practice. So let's look at a lab configuration that I have here. I need to publish this lab so you can run it yourself. Right now, this is kind of hand-baked at this point. But just to run through what we have in this configuration, this would look similar to something you might run yourself in your enterprise, right? So you typically will have some hub and spoke implementation, right? So we have an on-prem over here where I'm running a host. For me, this on-prem is actually in Azure because I didn't have time to set up my local VPN connection to Azure. So let's just pretend that this is actually an on-prem environment connected over an express route. I have a VNet hub where I have my DNS server running. And then I have 3 spokes. Let's take these kind of one by one here, just to, again, not overload the diagram a bit, okay? So spoke VNet A. Spoke VNet A has an AKS cluster using the traditional private deployment, right? So the deployment was set up to say, look, I want to let Azure create the private zone for me, link it to the VNet, and I'm not going to do anything else beyond that, right? So this is also using Azure DNS. Let's take a look at what that command would look like. So if you're going to run these commands, this is basically what that creation looks like. And in fact, for this, we wouldn't have even really needed the assign identity here. All we really needed was the VNet subnet ID. The managed identity and assign identity was really just because I was copying and pasting. For this case, you wouldn't need that. You're just enabling private cluster. That's your main concern, and specifying the VNet subnet ID, okay? So what that's going to give you, if you run this version, let's jump back over to the portal here and take a look at this one. So let's go to, I think this is my spoke A, okay? So here, this is my spoke A cluster. This is the managed cluster resource group, the MC resource group. And you can see a couple things in here. First of all, here's my private zone. So Azure created that private zone for me in the managed cluster resource group. It created the private endpoint. All that stuff is completely managed for me. If I pop this open, you'll see here's my A record for my cluster. We're all good there. If I jump to virtual network links, you'll see that it has also gone ahead and linked this to a VNet for me. So I didn't have to do any of that. All of that was managed for me in advance. And if I jump over to, not this one, let's move this one over. If I jump over to here, cancel, and let's do cluster info. All right, I'm connected to that one and all's well. And I'll talk about this bottom pane in a second, but I'm able to connect to that from my on-prem. I'm good to go, and I'll talk about how that connection works. But this is fully managed for me. I didn't have to do anything there other than some of the on-prem gymnastics, okay? So jumping to option 2. All right, so this is the second one that we talked about. So Spoke B is running an AKS cluster, but in this case, I'm bringing my own private zone. So I went out and pre-created a private zone. And then when I created the cluster, I specified the resource ID of that private zone. Now, again, I need rights. Whatever identity is creating this cluster needs rights to create records in that private zone. And also, I need to have gone ahead and pre-linked that private zone to whatever VNets it's going to be used from, right? So let's take a look at what that command looks like. So very simple setup here. Scroll down, take a look at the second one here. I have to delete my subscription ID from here. No. Don't use it for evil. Okay, so if you look at the private zone down here setup, what I'm doing is I'm doing AZ AKS create, giving my cluster a name, private cluster again. This all looks the same. I'm enabling managed identity. I'm giving a managed identity, right? So this is where it starts to be important that you have your own assigned managed identity, because I've gone and pre-authorized that managed identity to do things like, write records to the private zone, access the VNet, all those different things, right? There's the AKS network contributor role. There's the private zone contributor role that had to be allocated for that. And then finally, the VNet subnet ID. So popping over to the portal here, let's take a look at what that configuration looks like. Okay, now this is the managed cluster side. Now notice the difference between these two. In this case, now we're in Spoke B. There is no private zone, right? It didn't have to create a private zone. It still created a private endpoint. So if I click on this, I can see, yeah, here's my private endpoint. I can get my IP address and all that good stuff. But where's my private zone? Well, it's actually in my resource group where I have all of my clusters, right? So I have cluster A, B, and C, and I have in here this private zone. So I had to create that private zone as private link.east.us.azmkh.io. But once that was created, this record here, this A record that's in there, was completely managed for me. I didn't have to do anything there. That was created because I granted the cluster access rights to do that. All right. I did have to, if I look at this private link, join this to the right networks. I actually didn't need this in the hub. I should probably remove that, but Spoke B is where I'm using this thing. So anyone who's trying to call it that needs to resolve addresses, I need to make sure that I've added those links in there as well. All right. And now for the final one. All right, so looking at this last option we talked about, this is completely bringing your own DNS, right? So in this case, still have the private link. I have my own cluster in here, but I'm using custom DNS from the hub and no private zone at all. There's no private zone created for that. So taking a look at that one, I think first it makes sense to look at the actual network itself. So while Spoke A and B, I believe I'm not lying here, if I look at the DNS servers for here, yeah, that's using default. Good, I didn't mess that up. Spoke B should also be using default. Yep, good. Now we take a look at Spoke C in the DNS. And this one's using custom. Okay, so I am pointing this to the bind server that I'm running. So I went and deployed a VM, installed bind on it, configured it to be a DNS server. So I'm using that, and I'll show you the internals of that briefly. I also put in this recursive resolver. There are better ways to do this, but this is just an easy way to make sure that as my nodes are coming online with their own host name resolution, that they're not gonna fail. Per when we talked about host names a little while ago, this is important because otherwise your cluster won't come online. You can't talk to other Azure services and things that it might need to access. So somewhere in your DNS architecture, whoever your DNS engineer is, needs to go look at that doc that I showed earlier to see what option you want to route to make sure you're able to get to this recursive resolver. Okay, so if I jump over and let's take a look at that cluster. So cluster C, pretty much identical to B from this perspective, right? There is no private zone. There is an API server endpoint, right? So here's my private link for that. But otherwise, this is identical to B in every way. The only real difference is that no one created a record for me. Like Azure didn't go and create a record for me. I'm responsible for that A record entirely, okay? So looking back at this diagram here, right? No one created an A record. So in order to talk to this cluster, whoever is trying to talk to it needs to do a DNS lookup and needs to get back the API server endpoint, right? So in this case, what I have is my on-prem host is using this DNS server here. And in this DNS server, I've actually created records for this. In fact, I've actually created records for all of these. I didn't have to. I could have set this DNS server up to do conditional forwarding. But for the sake of demo, I just set this up so that spoke A, B, and C would all resolve from this DNS server for my on-prem users, right? Like I said, I could have done for on-prem to do a conditional forwarder, but that was kind of beyond the scope of what I was trying to go through here. So let's take a quick look at this. Oh, wrong one. All right, so right now, if I cancel this, I'm actually on the bottom screen here, I'm in my bind server. So if I look here, I have a zone file. If you're familiar with bind, effectively what you end up doing is you create files that contain all the DNS records. So let me expand this a little bit and show you what I have in here. Let's nano this, pb.private link. Okay, so here there's a bunch of gobbledygook at the top, but at the bottom, what you're going to see is here's all of the records. Now I could kill a couple of these. I don't really need these, right? You just comment those out, but you can see that each of these has the DNS name that was provided for me. If you look at the cluster, and says where the private link IP address is. So let's kill this. Oops. Forgot to do sudo. So let's do that again. And let's comment these out. It's weird to comment with semicolons, by the way. I keep putting hashes in there. All right, let's do a restart on bind. Okay. So now from here, if I go and try to do let's do a kubectl ctx, just to switch to a different context. If I go and try to, so right now I'm connected to spoke A. If I try to get nodes there, it's going to fail for me because it can't do the DNS lookup. I just removed that DNS record, right? You'd see the same thing with spoke B. Let's do AKS spoke C. Oh, there we go. And let's do get nodes on that. And that one should resolve just fine. Pods, everything should be working. All right, let's do pods this all. Okay, I can jump back down here. I can fix the bind server. So let's go back down here and let's open these ones back up. All right, let's restart bind again. And now let's do kubectx, switch back to A. It's now looking at spoke A. Let's get nodes. And now I'm back online, right? So now, having that bind server, my on-prem machine can talk to any of these clusters because I've created the A records. Of course, there's more elegant ways you can do that, but that's kind of the short and sweet way, or just doing a local host file. So with that, we ran through a ton of DNS stuff. It really comes down to ultimately your decision about these three options. If you're doing private clusters, do you want Azure to completely manage it for you? Do you want to bring your own and maybe have a little bit more control over those zones and what VNets they're connected to and so forth? Or are you just going to completely roll your own DNS and manage it yourself? If you do go with option one, there are some helpers out there. I mean, the main challenge with option one is, okay, how do I make sure that all of my VNets are linked? And as I'm creating new nodes, how do I make sure they get applied correctly? There was a function that was created by one of our peers, an AKS zone auto linker. which will go out and automatically, as it sees clusters come online, will do all the linking for you to your VNets, et cetera, et cetera. So that's something you could look at for that. But as an alternative, as I mentioned, probably the way you'd end up going at this point, now that this is available in preview, is to just use this option and create the zone in advance and manage it that way. This came out in preview in December. I don't have a specific date on when it'll be out of preview, but I don't suspect it'll be too long because it's a pretty straightforward feature. So I think it's really just a matter of waiting for enough people to get on it that the engineering teams feels like they've properly vetted the solution and all the issues have been worked out. So with that, I'm going to open it up for questions.
Yeah, I know, Steve, there are a couple in the chat window. Can you see your chat? Because I'll let you go through them and moderate.
Can now.
Okay.
Yeah, I can now. Sorry. I hate how the chat disappears, like the whole window disappears when you're presenting. Okay. Right. Does the name of the private zone have to be private link? Yes, it does. Because that's what that zone, for now, I think there's existing feedback that you want to be able to bring your own cert, right? So that's a really good question, because as it stands today, we're still generating the cert. We're still generating the FQDN based cert. So it has to be that Azure provided naming standard. Now in the future, I know the feedback is there, and hopefully we'll have the ability for you to bring whatever DNS name and bring your own cert, but that's not there just yet. For the bring your own, please, the AKS cluster must use MSI. Correct, yeah, for bring your own private zone, currently requires you to use MSI per the docs. Can bring your own private zone be used to connect to an AKS in another subscription? So the zone, yes, the zone you should be able, I've not tested, but because it's based on resource ID, as long as it's within the same tenant, the zone should be able to work across subscription. It would be a good thing to verify and test. And if it's not working, the engineering team should address that. But again, because it's using resource ID, it has the assumption that the subscription ID is part of that, so it should work cross subscription. All right, can you share one use case where your customer asked you for private clusters and you pushed back and they were able to convince you to do private clusters? When customers convince me to do private clusters, it's generally because there's some audit and compliance requirement, like in the FinServ industry, like thou must not have private endpoints. But even that discussion, Azure Resource Manager is a public API, right? And it's locked down with Azure Active Directory, multi-factor authentication, and so forth. They don't always agree with me, but they've never been able to convince me. It's pretty rare they've been able to convince me that you absolutely must have private clusters. Again, because the fallback discussion is, well, all of the public cloud providers' endpoints for doing deployments are public, right? So, you can already mess it up by making call to ARM if your ARM is insecure or your Active Directory is compromised, right? So that'd be my discussion there. Okay. So what was the difference in commands in scenario 2 and 3? Yep, that was the only difference. The only difference you saw was that it changed to none, and I can share my screen there. But yeah, that was the only change. Sorry, I didn't highlight it. Let me bring it back up so everyone can see if you missed it. Okay, so the only difference between 2 and 3 was that in this one, we did none. Oops, sorry, that's the wrong one. I think I copied and pasted incorrectly. But what you would have seen was in one of them, we actually had the full, this is a bad view. I copied over and pasted it. In the private DNS zone, you would have seen the full DNS zone called out here. You would have seen the resource ID. Let me actually fix that now so that you can see what I'm talking about. Again, I accidentally did a copy and paste on that one. So what we need is, let's go to DNS zones. Let's get the zone ID. If I hadn't copied and pasted wrong, what you would have seen was this. This is B, right? Yeah. That would have been the only difference. And again, apologies for the copy paste error. Right, so in this one, you're giving a private zone resource ID. And in this one, you're setting it to none. That's the only difference there. All right. See if I can bring this chat back up. All right. So the service CIDR, 10.0.0.0/16, the DNS service IP. Yep. Documentation says to use this CIDR and DNS IP. Does that change when using AD? Well, you know, the service CIDR and DNS IP, that can be anything you want it to be. The DNS service IP has to be in the service CIDR for one, but the service CIDR itself can be whatever you want, right? So the service CIDR, as long as it's not overlapping with existing address space, and you can reuse that service CIDR across multiple clusters. The main reason that you don't want that to overlap is that it's creating IP tables rules, and there's a possibility that as traffic is going between nodes, as you're making calls around, that service CIDR, which is used for cluster IPs, it's not accessible from outside the cluster. It's only routable within the cluster. But as traffic is going between nodes, you could land on your route table, and your route table says, oh, well, that IP address, that's way over here, or that's on-prem, and it just fires the traffic off to the wrong direction. So that's the main reason you want that service CIDR to be unique. And then DNS IP just has to be something within there. So yeah, that can be really whatever you want. And you don't have to change it based on AD server or anything like that. Cool. Any other questions? Yeah, I'm so annoyed that I had that copy paste error. Good catch, Mario. All right. Can we use the same value? Sorry, can we use the same values of service CIDR, DNS service IP, Docker bridge CIDR, pod CIDR? Yeah, yeah, it's always fun. Okay, so they should be separate ranges. So first of all, the Docker bridge is going to become irrelevant because that's only used for bootstrapping Docker and so forth. If you're doing Docker in Docker and so forth, so that's going to become irrelevant because we're switching over to the CRI. But with the pod CIDR and the service CIDR, those should be separate because again, it comes down to rules that are created in IP tables. So if they're overlapping, then you can cause all kinds of havoc. So you do want those to be separate CIDRs within your cluster, and you generally want to avoid. You definitely want to avoid those overlapping with other address space that you're using within your cluster. But in both cases, you can use those same pod and service CIDRs on multiple clusters. So you don't have to create a unique pod and service CIDR for cluster A and unique one for cluster B. It's really about making sure that when traffic exits the node and hits the VNet, a route table doesn't accidentally pick it up and throw it somewhere, right? If your route table has routes that have been propagated via BGP from on-prem, and there's some CIDR in there that overlaps with your cluster, weird things can happen. You can start having packets disappearing and things like that. And the funny thing is they'll only disappear in certain scenarios, right? Because if you're routing traffic within a single node, well, it's not going to hit the NIC. So it's not going to hit the VNet, no issue. But as soon as that traffic crosses between nodes, then weird things start happening. So maybe like, depending on the scenario, maybe 25% of your packets are dropping. It's like, well, what happened? Well, 25% of your packets have an overlapping IP that's getting sent on-prem, right? Okay. If you have two AKS clusters using the same private zone, is there any risk of them messing up the zone? Some tips. So option B. Well, if you look at the names that are generated, they're all unique. They all have GUIDs on them. So even if you had two clusters of the same name, ultimately the zone would be like my cluster name dot subset. I can share a screen and show this as well. The subset of the IP. Let's take a look at this one. Let's cat that private link again. Or nano it. So you can see here that the zone name itself is actually my cluster name plus the resource group name plus some subsection of my subscription ID plus a GUID, right? So you're pretty unlikely that you're going to have some overlap there. That would be the main concern, is if you have overlap. The other concern would be is, hey, you got a bunch of clusters in here, and some Yahoo went in and started deleting things, right? They went in and deleted A records, like they were saying, hey, what's this cluster doing here? They deleted an A record. Okay, well, you're gonna have a problem, right? So whoever is responsible for this is going to need to be aware of what they're doing, and make sure. Were you actually able to see my screen? It looked like it just flipped weird. Okay, though, to make sure that they didn't actually mess something up in there. All right. Cool. I know we're just about out of time. I know, Kendall, you had an announcement to make. Looks like you posted it. I don't know if there's any other quick questions. Otherwise, I think we can wrap it.
Thanks so much, Steve. Yeah, this was awesome. I know it's a really complicated topic, so I'm sure we'll have a lot of hits on YouTube, people referencing this in the future. But yeah, just remember next time we're going to have the PG on, and so definitely of all of those sessions, I would say it'll be one of the ones that you don't want to miss. So definitely check that out and make sure it's up to date on your calendar. But thanks everyone for joining. Feel free to reach out. The recording of this will be up by the end of the day, and all the links will be up within the next 10 minutes or so.
Cool. All right. Thanks, everybody. Take care.